Sorry about that, guys. Evan decided he really needed the computer, and when he grabbed it, it paused the video, and I didn't know how to get it restarted. So here we are in part 2. As I had said, the Mesozoic era is the appearance of the dinosaurs. We're also seeing your earliest ancestors, the small mammals, are developing. In terms of plants, we see flowers are appearing. Flowers are the most advanced reproductive strategy that a plant has. It allows them to create a lot more genetic diversity, and this is the first time we see that happen. At the end of the Mesozoic era, we get the mass extinction. We kind of talked about that a little bit yesterday. But what's interesting here is that only about 50% of life is dying out during this extinction. As I said at the end of the Paleozoic, that was 95% of life was dying out. So even though this is probably the extinction you are most familiar with, that doesn't necessarily mean this is the largest extinction. The last or most recent era of Earth's history, the one we're currently living in, is the Cenozoic era. And the Cenozoic era is marked by the fact that mammals are dominating the Earth. As I said, you are a mammal. It didn't start out with humans dominating the Earth, but some of those large mammals, think the woolly mammoth, the giant sloths, all things like that. But it does also mark the appearance of our human ancestors. As I said, this is our time. It started during the Ice Age, and it is continuing into present day. Biggest takeaways from the Cenozoic era is mammals are ruling the earth and the appearance of our human ancestors. And the fact that this is our most recent, most current era. It's only been for about the past 65 million years, not even close to a billion yet. So realize we'll probably be in this one for a little while. All right, so those are the eras of Earth's history. That's what you were kind of taking a look at last night. In terms of the rest of this note sheet, I want to talk a little bit about the fossil record. Okay, the fossil record is going to be our first major piece of evidence that we start talking about. And as we build out this unit, we're going to talk about all the pieces of evidence that scientists have for evolution, just to give us this idea of why we know all these organisms have changed over time. The fossil record is probably the easiest to understand because it provides just basic clues to our past. So how are they figuring this out? How do they know about all these different organisms? One of the ways is through the fossil record. The fossil record is all the information that paleontologists have uncovered over the course of Earth's history. Okay? This gives us evidence about the life on Earth because we found fossil remains of some of them. And it's important to note that most of the species that's lived on Earth are now extinct. Realize, though, it's difficult for a fossil to form. So we don't necessarily have fossils for every single Evan decided he wanted the iPad. Let's see if he'll read his story on his phone. Do you want me to undo buckle my shoe? But the idea here is that more than 99% of the species that ever lived are now extinct. Realize, too, that we don't necessarily have fossils of everything that's ever existed because a fossil is actually pretty tough to make. There's different types of fossils. You don't have to know tons about this. I like seeing some of them. Sedimentary ones, which are similar to this type and this type, those are going to be the easiest ones to form. This guy is an amber fossil. If you've watched Jurassic Park, that's how they built it out and said that they got the blood from the dinosaurs. It was from a mosquito preserved in the amber. This is petrified wood. Basically what happened was a log fell, died, and the minerals seeped in and have taken the place of that organic material. So how do fossils form? It has to be a pretty precise condition in order for that to happen. And most form, like I said, in sedimentary rock. Sedimentary rock is all of these different layers over here. If you've ever gone to like the Grand Canyon or seen a riverbed and you see how there's layers of rock along the side, That's your sedimentary rock. Okay? If the conditions are correct, they end up trapping the dead remains in the layers of rock, and then they end up filling the minerals in. One thing that you do need to know is that the word strata means layers of rock. Okay? Strata means layers of rock. Other methods of creating fossils could include volcanic ash and amber, like you kind of talked about. And like I said, fossilization is a rare event. It's not always going to happen, okay? And not everything is going to be preserved. All right, in terms of interpreting the fossil record, we have two major ways of doing that. Number one is going to be relative dating, and this is going to be the first one that we focus on. The idea of relative dating is that the oldest fossils are found at the bottom or in the lowest layers of the strata, okay? The youngest fossils are then going to be found at the top, at the highest level of this. Meaning if we were to look at this layer of rock over here, my oldest fossils are down here. So I'm just going to mark this as old. And my youngest fossils are up here, young. Okay, those are the most recent. That's why they're in that most recent part of the layers of rock. Okay, the other way that we can interpret the fossil record is based on radioactive dating. In radioactive dating, you're calculating the age of a rock based on the amount of remaining radioactive material. That sounds really tricky and really complicated. We're going to talk a little bit more about this later this week, and hopefully Thursday and Friday we'll go over the basics of how that works, and then we'll get into actually looking at these. You guys are going to be responsible for understanding how to read graphs that look like this, where it shows you how much of that radioactive remains and what's happening from there with it. You can hold it. Okay, so that's kind of where you're at. I'm going to ask you guys to take a look at the Barbella's. You know what? I'm not going to ask you to take a look at the Barbella's slab. That's what we're going to talk about tomorrow. We're going to make something called a cladogram tomorrow, and this is going to be where we're creating an evolutionary tree. We'll get into this in a little bit more detail tomorrow and be ready to do your Barbella's slab. Thanks, guys, for putting up with this. Sorry that you hear Evan screeching. Evan, can you say hi to Mommy's kids? Can you say hi?
No.
Evan, what are you watching? He's watching his choo-choo. Sorry, guys, again. I'm really, really sorry. I hope you guys have a great day. I will hopefully be back tomorrow.